Hello Year 11 Mathematics Advanced students. Today we're doing the intersection of graphs, which is the last part of the topic of functions. So we're going to talk about a couple of different methods of finding the intersection of graphs. The first method is to solve equations graphically. So let's just jump into some examples. So to find the intersecting points of graph y equals x squared and y equals 1 on the same set of axes, and hence solve x squared equals 1. So we know that y equals x squared is a parabola. So that means it will, and it's a perfect parabola too. So let's plot our points. So this is the point 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, and minus 5, 1, 2, 3, 4, 5. Alrighty, so our parabola goes to the point 1, 1, and minus 1, 1, and then goes to the point 2, 4, and minus 2, 4. Okay, so this is what our parabola looks like, and it goes to the point 0, 0. Like so. And then y equals 1 is the straight line that is horizontal going through the y-axis, sorry, at 1, if I can get it to look proper. There we go. So let's label both of those. So that's y equals 1, and this is y equals x squared. So therefore, to solve this is we want to find out where they intersect. So these two graphs intersect at the points here and here. So they intersect at the point minus 1, 1, and they intersect at the point 1, 1. So we want to find the solution of x squared equals 1. So the solution is x equals plus or minus 1, because we want to find the x values of when this occurs. For example 2, we want to sketch x squared minus x on the same axis as y equals 2. So what we're going to do for this one is I'm going to actually first sketch y equals 2, but we need to make a scale on our axes. Okay, I suppose I should go down as well. Minus 1, minus 2, minus 3, minus 4. Okay, so for the line y equals 2, I'm going to do that first. So that is the straight horizontal line going through the y-axis at 2. So y equals 2. And then for y equals x squared minus x, I'm going to find my x-intercept. Actually, I'm going to do a table. Yeah, I'm going to find my x-intercept. So x-int, we need to let y equals 0. So it'll be 0 equals, I'm going to take a common factor of x at the front, x minus 1. So there we have the x-intercepts 0 and 1. So 0 and 1. I'm then just going to find some values. So I'm going to draw up a quick table of values for this. Doesn't have to be perfect. So it's going to do minus 2, minus 1, 0, 1. and I'll add 2 in there as well. Okay, so minus 2 squared minus 2 is 6. So let's plot that. That would be up there. Minus 1 squared minus 1 is 2. Then we know that 0 is at 0, and we know that 1 is also at 0, and then we just need to sub in 2. Awesome. So our graph is going to look something like that. Add our arrows and label y equals x squared minus x. So our point of intersection is where they cross. So, and it's our x values. So our x is at -1 and 2. So our solution is to solve that is at -1, 2. Now for intersecting lines. So 2 straight lines intersect at the single point x, y. So if we have a look at our picture down here, they intersect at the point x, y. The point of intersection, it can be found graphically, like we've just done, or algebraically, and we can use simultaneous equations when we do it algebraically. So let's find the point of intersection between the lines 2x minus 3y minus 3 equals 0 and 5x minus 2y minus 13 equals 0, solving them simultaneously. So to do this, we're going to write out our equations and we're going to label them. So we're going to label 2x minus 3y minus 3 as 1. And we're going to label 5x minus 2y minus 13 as 2. Now we're going to solve these simultaneously. And so to solve these simultaneously, what we're going to do is we're going to multiply equation 1 by 2. And when we do this, we get 4x minus 6y minus 6 equals 0. And we're going to call this equation 3. We're then going to multiply equation 2 by 3. And when we do this, we get 15x minus 6y minus 39 equals 0. And we're going to call this equation 4. Now you notice what we have created is we have created the same pronumeral for our y of minus 6. So we can eliminate our y by going equation 3 minus equation 4. And when we do that, we get 4x minus 15x is negative 11x minus 6y minus 6y cancels out to be 0, and negative 6 minus negative 39 is plus 33 equals 0. We're then going to minus 33 to both sides of our equation. So we get negative 11x equals negative 33. Divide both sides by negative 11. And we get x equals 3. We're then going to find y, we're going to sub x equals 3 into equation 1. So when we do this, you can pick any equation 1, 2, 3 or 4 that you like. So it will be 2 times 3 minus 3y minus 3 equals 0. So then we have minus 3y, 2 times 3 is 6, minus 3 is plus 3 equals 0. We're actually going to add the 3y to both sides of the equation to make it positive. So then we have 3 equals 3y. Divide both sides by 3. And we get y equals 1. So therefore, the point of intersection is the 0.31. Moving on, we have break-even points. So in business, the break-even point is where the income equals the cost. So if the income is greater than the cost, then the business is making a profit. If the income is less than the cost, then the business is making a loss. So looking at an example, a company that manufactures cables sell them for $2 each. It costs 50 cents to produce each cable, and the company has fixed costs of $1,500 per week. We want to find the equation for the income on X cables per week. So what we do is we're going to say that I equals something or other. So we want to find the equation for the income. So this is how much the company makes each week. And so the company makes $2 per cable each week. So we're going to go income equals 2 times our X. And that's our equation for income. I equals 2X. For part B, we want to find the equation of the costs in terms of $C for manufacturing X cables per week. So we're going to go C equals something. So each cable costs the company 50 cents. So we're going to turn that into dollars. So that's 0.5 for every cable. So we're going to multiply that by X, plus it has a fixed cost of $1,500. So that is the cost of our equation. We then want to find the break-even point, so where the income equals the cost. So we need to solve these equations simultaneously. So we're going to write out our equations. So I equals 2x and C equals 0.5x plus 1,500. And we're going to label these equations 1 and 2. We're then going to let 1 equal 2. Because we are told here that to find the break-even point, it's where income equals cost. So we got to let our income equal our cost. So letting our two equations equal each other. When we do that, we get 2x equals 0.5x plus 1,500. We are then going to minus our 0.5x to both sides of our equation. I'm just going to come up here to finish this off. So when we do that, we get 1.5x equals 1,500. Divide both sides by 1.5. And when we do this, we get x equals 1,000. So therefore, we need to then sub x equals 1,000 into either equation. I'm just going to sub it into 1. So then we get the income equals 2 times 1,000, which equals 2,000. So therefore, the break-even point is 1,000 and then 2,000. Okay, so therefore 1,000 cables gives income and cost of $2,000. Meaning that they're not making a profit and they're not making a loss. Finally, we want to find the profit of 1,450 cables. So how we calculate a profit is that we go income minus our costs. So to do this, it is the same as I minus C. So we're going to substitute. So we're going to sub x equals 1,450 into both equations. So it would be sorry about that, would be I equals 2 times 1450, which equals 2900, and C equals 0.5 times 1450 minus 1500, which equals 2225. So therefore profit will equal I minus C, which equals 2,900 minus 2,225. So our profit equals $675. Finally, we're going to talk about intersecting lines and parabolas. So a line can intersect a parabola at 1 or 2 points, or they may not intersect at all. So this first one has an intersection at 1 point, this one has an intersection at 2 points, and this one does not intersect at all. We want to find the points of intersection of the line y equals x minus 1 with the parabola y equals x squared plus 4x plus 1. And we're going to solve this algebraically. So we're going to write out our equations. So y equals x minus 1 and y equals x squared plus 4x plus 1. I'm going to label them 1 and 2 so that we can solve them simultaneously. And we're going to let 1 equal 2. So we're going to let them equal each other. So that means we'll have x minus 1 equals x squared plus 4x plus 1. I'm then going to move everything to one side of the equation. So we're going to minus x and plus 1 to both sides. So we get x squared plus 3x plus 2 equals 0. And we can then factorize this to get x plus 2 in one bracket, x plus 1 in the other equals 0. So therefore our x values will equal minus 2 and minus 1. We're then going to sub x equals minus 2 into 1. So we'll get y equals minus 2 minus 1. So y equals minus 3. And we're going to sub x equals minus 1 into 1. So we get y equals minus 1 minus 1. So y will equal negative 2. So therefore the 2 points of intersection in this case are negative 2, negative 3, and negative 1, negative 2. And that is all for the theory notes for this topic. If you're following the advanced textbook, you would now do exercise 3.14. If you're following the extension 1 Maths in Focus textbook, you'd do exercise 4.15.